good morning, good afternoon, or good evening, or at any time you're watching this video. So today I want to present in this video about what have I learned in PHY110 in this semester, which is my second semester in UITM Campus 2. So basically I want to present in this video about chapter 5 in PHY110, which is about thermal physics. So basically, thermal physics is the combined study of thermodynamics, statistical mechanics, and kinetic theory of gases. So this umbrella subject is typically designed for physics students and functions to provide a general introduction to each of core heat related subject. Other authors, however, define thermal physics loosely as a summation of only thermodynamics and statistical mechanics. So thermal physics can be seen as the study of systems with large number of atoms. It unites thermodynamics to statistical mechanics. So let's move on. But before that, generally thermal physics is study of the statistical nature of physical system from an energetic perspective. So starting with the basics of heat and temperature, thermal physics analyzes the first law of thermodynamics and second law of thermodynamics from the statistical perspective in terms of the number of microstates corresponding to a given macrostate. So this chapter is very related to one of the chapter in chemistry, which I learned in this semester. So let's move on. So heat and temperature. Heat and temperature are closely related topics, and as such, the difference between the two can be a bit confusing. The core difference is that heat deals with thermal energy, whereas temperature is more concerned with molecular kinetics energy. So, what's the difference? Let me tell you. Heat describes the transfer of thermal energy between molecules within a system and is measured in joules. Heat measures how energy moves or flows, and an object can gain heat or lose heat, but it cannot have heat. Heat is a measure of a change and never be a property possessed by an object or system. Therefore, it is classified as a process variable. Next, temperature describes the average kinetic energy of molecules within a material or system and is measured in Celsius, Kelvin, Fahrenheit, or Rankine. It is a measurable physical property of an object, also known as a state variable. Other measurable physical properties include velocity, mass, and density, to name a few. So what's the similarities between heat and temperature? So heat is a transfer of thermal energy caused by a difference in temperature between molecules. Take note, thermal energy can be otherwise understood as the total microscopic, kinetic, and potential energy of a system. So let's move to the second one. I want to conclude about heat and temperature. So distinction between temperature and heat and states of matter. So number one, temperature is a measure of average kinetic energy of individual molecules. It defines hot or cold. So number two, heat is the degree of hotness of an object or a transfer of energy due to a difference of temperature. So here is the table that shows the differentiation of temperature and heat. So definition, the temperature is the degree of hotness of an object, and while the definition of heat is the amount of energy that can be transferred from hot object to a cold object. So the unit SI for temperature is Kelvin, which is K, and Joule for heat, which is J. Measurement instrument for temperature is thermometer, while heat is using joule-meter or calorimeter. So is it temperature is a base or derived quantity? So it's a base quantity, while heat is a derived quantity. Talking about scalar and vector quantity, temperature is a scalar quantity, while heat is also a scalar quantity. So we are talking about temperature again. So temperature is a measure of how hot or cold something is. So many properties of matter changes with temperature. Most materials expand when they are heated, such as rubber or plastics or metals. Next, what are the things that are used to measure the temperature? So thermometers are the instruments that designed to measure temperature. So temperature is generally measured using either the Fahrenheit or the Celsius scale. In scientific work, scale is the absolute or Kelvin. The freezing point of water is 0 degrees Celsius or 32 Fahrenheit. The boiling point of water is 100 degrees Celsius or 212 Fahrenheit. So that is the example of the usage of thermometer. They measure the how we measure the temperature. So the conversion between both scales can be given as when we want to measure temperature in Kelvin, 1 degree Celsius plus with 273.15. So next is states of matter. Matter exists in four different states or phases, which is solid, liquid, gas, and plasma. Solid, the first one is solid. The solid state of matter is when the material has a definite volume or size and distinct shape at a given temperature. A piece of iron at room temperature has a shape and size that does not change. Ice is another solid, but its temperature must be below 0 degrees Celsius, which is 32 Fahrenheit. Next is liquid. A liquid has a definite volume, but it takes the shape of its container with the help of gravity. If you pour water into a cup or a container, it will take the shape of the container. If you put water in a balloon, the water will take the shape of the balloon. No matter how you change the shape of the balloon, it will stay following the shape of the where it is placed. So next is gas. The volume of a quantity of gas is dependent on its temperature and the surrounding pressure. If affected by gravity, it will take the shape of its container, but much of it will also spread out into the surrounding area. So I think this is it. I think I talked too long because yeah. And remember, heat is not the same as temperature. So that is all for me. Thank you very much.